So in last class, we were seeing features of Python. So in the features of Python, we have already seen up to robust language, why Python is known as one of the robust language. The eighth one is object-oriented programming language. So I'll be skipping this particular feature, that is object-oriented programming language, because if I try to make you understand this object-oriented programming language, you will get confused for now, right? Because we should not move on directly to the oops concept. That is a most important concept in the programming language, and we have to be really careful while learning this. Okay, so I'm not gonna make you confused, or definitely will get confused with this if I try to explain this now. So immediately we will just skip this particular part. When it comes to oops concept, we will be seeing what is object oriented programming language, what is class, what is object, what is encapsulation, inheritance, and so many things we have, right? So I'm just skipping this particular part for now. We will see what is extensible and what is embedded. Okay, what is extensible? Python is one of the extensible programming language because it offers its programming features to other programming language, making Python one of the extensible programming language. As well as, along with this, I will also go for Python can speed up things by calling code from other programming languages. For example, Python can call code written in C for faster execution. Now, let me give you a simple example for this. If it works, then we will go for it. So everyone knows YouTube, right? Everyone uses YouTube, right? Now, if I talk about the previous, I can say, like, if I talk about last couple of year back, the scenario was YouTube was using C programming, Python programming together. Okay, that means YouTube was using 50% of C programming. That means code has been written in 50% in C programming, and 30% in Python, and the rest of the 20% other programming languages, other like front end and all so many things, right? So almost 50% of the code has been written in C programming language. Why? Because in C programming there is a concept of pointer which makes our programming execution bit faster. Okay, bit faster in execution. Whereas Python has so many different things, so many features, and so many different like modules concept are there, modules are there, which makes Python as one of the efficient programming language, right? So when we combine a programming language which is faster, and when we combine a programming language which is more efficient, then I can make one of the programming language which is, and I would say here it could be more efficient programming language, or more perfect application, you can say. Okay, that means what we are doing here, basically we are combining this C programming and C plus plus, sorry, Python, right? C programming and Python for the better execution. So here also you can just read it. It offers its programming features to other programming languages. That means basically what I'm trying to say here, this Python programming is giving some its facilities or programming facilities to C programming as well, so that if I do so with if I work together with C and Python, my application will more efficient. Okay, making Python one of the extensible programming language. As well as Python can also use the code of other programming language. For example, code written in C for faster execution, I can use it in Python as well. Okay, so this is the meaning of extensible and embedded. Extensible is nothing but we can offer that means Python can offer its programming features to other programming language, and embedded is nothing but in Python we can use other programming code as well, right? So these two terms are quite important, extensible and embedded for real time, right? As well as it also supports third party libraries. So what it says, to boost up the efficiency of traditional Python programming, we rely on third-party tools like NumPy, Pandas, Matplotlib, Seaborn, SciPy, okay, sklearn, and many more. To use these tools, we simply install them using tool called pip. Okay, pip is nothing but Python package installer it is, and that is the need of this is basically it is one of the tool we have which is used for installing a, I can say, third party API. Okay, third party API. API is nothing but the collection of modules. So basically, when we want to install the library in our Python software or in our system, okay, we have to go for the pip tool here. So I hope you have understood all the concept of what is features, how many features, whatever the features so far we have seen, and you are getting everything. Next concept we are going to see here is, let me go for it here itself. Next feature we are going to see is data representation. So first of all, I will show you what is variables and what is literals. See how we can how we can represent the data in Python, right? So data representation is really important in Python. So the data representation in Python is nothing but storing the data in the main memory. See this main memory, where we whatever we try to store, it stores in the main memory itself. To store the data in Python, we need literals, or we can also call it as values. We need variables, or we can also call it as identifier. And the last one is data type. Right. So now what is literal or values, or what is variables or identifier, we'll see. First of all, what is literal or values? Literals are nothing but these are the values itself. Okay, whatever the programmer enters, right, as an end user or as an programmer or whatever, what it says, literal are values entered by programmer or the end user or the application user to the real time applications, right? For example, if I tell you the example for this, I say is equals to 200. Here I would say this 200 is nothing but a literal or a value here. But behind this value also we have different types of literals. Okay. So when I talk about literals, we come up with integer literal, it comes up with float literal, boolean literal, string literal. How? So you can check here, if I try to execute this and if I try to print this, print of a. Here we know that 200 is an integer value, and I can check this as well with the help of type. Type of a is nothing but it is a class of integer, right? This is how we can check. But internally, whenever this is a programmatically, if I talk about this in program term, we call this particular value as an integer literal. Okay, integer literal. Similarly, if I go for something like this, let's say abc, abc, okay, this abc are character and coming inside what, a double quote or single quote, whatever quote you can use, these are known as what, string literal. Okay, if you go and check again, this is a string data, this is known as string literal. Similarly, if I go for this something like let's say true, True here. True is nothing but a Boolean value. So if you check here, it is a Boolean value. Also, I can call it as a Boolean literal here. Let's say is equals to something like 2.4. 2.4 is obviously it is a float. If you check this, it is a float. So I can say this is a float literal. So different type, different literals we have. Something like student number you write, employee number you write, mobile number, age. These are what? This comes under integer literals. Okay. When I talk about the float literal, percentage, height, weight, these are what? Float literals we call. Boolean literals. What are Boolean literals? True or false. String literals, name, gender, location, etc. Okay. So these comes under what? Different literals we have. Similarly, if I talk about the variables, variables are nothing but, I can say it is a container. Okay. In a general, if I say variables are nothing but it is a container. So now let's say I'll be giving a simple example. Why it is known as variable? Let's say there is a container. Okay, there is a container. Here it is a container, and inside this, let's say it is a pot. Okay, sorry, it is a pot. Let's say what we call it as, um, okay, chapati pot, I would say, something like chapati pot, where we keep the chapati, right? So every day we keep chapati, right? We keep chapati inside this. Inside this, we keep chapati. But is it possible for us to keep every day, to keep the same size of chapati, same size of chapati, same? Is it possible? No, obviously, right? Even though it is a container, there is 0.001% of chance that every day we will keep the same size of chapati, right? That means, can I say, day by day or every day this size of chapati may vary? Obviously, because every day we can't keep same size of chapati, right? Until we use some shape, some structure, right? So I can say the size of chapati every day may vary. Okay, that's why whatever this container, this is a container. We call it as chapati pot, right? This is a pot, and this is a container which basically stores the chapati, right? Similarly, if I talk about programming language, when I say 10, 10 is an value, but we need to store this inside one variable. Okay, that variable is nothing but, I can say, I can call it as a number. Anything you can take, any name you can take. This number, basically it is a container. Okay, this is a container, and this container is nothing but which holds the value, which holds the value, holds the value. And these values may vary, right? So what it says, you just read this. Once the application user enters the data from the keyboard to program, it is programmer's responsibility to store the data in variables or identifiers, right? Hence all literals or values or data must be stored in the main memory in the form of identifier or the variable. Otherwise we can't process the data. This you have to understand here. Is it clear, guys? Just give me a confirmation. Is it clear? So here you can see here A is equals to 20, B is equals to 30. And these are my A and B are what? My variables, where 20 and 30 are literals or values, you can say. When we define it, the C is also, it is one of the variable. Okay, already I have defined it here. You can see something like this also. I'll just go with this. Right, if you say something like a is equals to 20, b is equals to 30, c is equals to a plus b, and if I print c, you can find out here that if I print c, you can find out the data. Here I would say a and b are what, are variables, okay, and 20 and 30, 20 and 30 are values, or we can also call it as literals, integer literals you can call it as, right? Now some rules we have, rules also we have to understand for declaring the variable. What is the first rule? Variable names in Python can contain combination of alphabets, digits, and the underscore symbol, that is this symbol, right? So I can take some characters, okay, I can take some character that says alphabets, digits, and underscore. So I can say something like name 1 is equals to Ram, okay, age 1 equals to, or let's say you want to take underscore, you can take age underscore is equals to 200, something like this. You can take underscore age as well is equals to 200, okay, that is also fine. You can take name 123 and then age is equals to 200, okay, that is also fine, right? But what it says, the name must start with either alphabet or underscore, right? We can't start anything with anything like 200 name is equals to 200. Here it is going to give syntax error because we can't start any variable name with a digit here, right? Yes, I can start with underscore, underscore name is equals to, let's say, Ram, like this. I can access it, I can use it. I can't use 12 name is equals to uh, Ram, okay, this is wrong. Yes, I can use name 12 like this, and you can use like this, and that is fine, okay. Next it says keywords cannot be used as the variable name. Keywords are nothing but these are reserved word, okay, these are the reserved word in Python, that means which has an specific meaning, that is meant for something else, right? We can't use as our variable, so we can't use the keyword as our variable name. For example, we have some different keywords, right? So if I write something like if is a keyword in Python, and if I try to store if is equals to 200, it will give an error. Similarly, if I try to go for else is also one of the keyword. If I try to go and store, here also it is giving error. While is also one of the keyword. While is equals to 200. See, every time it is providing one error called syntax error, right? Similarly, if I go for something like del is equals to 300. So here del is also one of the keyword. I will tell you what this del, while for is also a keyword. For is equals to 200, for is equals to 200, that is also. Special symbols are also not allowed, right? So if I write something like name, but name at the rate I am providing 300, here it is giving name, okay, that is different thing, but it should give one syntax error because it is having name already, we have defined it over there. So it is asking for, did you mean name 1? So I don't want to take that name 1, right? Similarly, if I say something like age uh, dollar is equals to 200, check it, we are getting syntax error. Similarly, age percentage, we are getting syntax error, name error, because age underscore already we have, so it is asking something like this. Similarly, it is just giving a suggestion, right? Some slash if I give, it is giving something like this. Okay, let's change this to something like, I'll take gender we haven't taken, okay. Let me do one thing, I'll just clear this. So gender I will take, gender is equals to um okay, gender at the rate, I would say, okay, gender at the rate 200. So you can see here name error, name gender is not defined, right? Similarly, I would go for gender, this particular symbol, here also it is saying Okay, and I'll go for star. So here also it is saying name error. Similarly, I'll go for different special symbols. It is every time it is gonna give only one special symbol is allowed, that is what we call it as underscore, right? Underscore is allowed. You can take gender underscore. If you print, you will be getting the value what you have stored. I hope it is clear for you guys, right? So this some, yeah, here I would say last one called um, spatial symbols except underscore are not allowed as variable name. Okay, something like this. So special symbols also you can't use here, right? So I hope you are able to understand what is this data representation, variable and literals. Okay, any question, guys? Do you have any question? Prasanna, Luthia, and Dev.
No, sir.
Fine, it is. Right. Next is we will be moving into data types. Okay. So in Python we have 14 types of data type. Okay. In Python we have 14 types of data types. What these are? First of all, I'll just go for the copy it, just to go for different. Third is data types. Now I'll be writing the notes. Okay. So what is the purpose of data type? It is nothing but to allocate the memory space in the main memory, right? So the purpose of data types is to the memory space allocate the memory space to or in the main memory, in the main memory. Okay, main memory is fine. Okay, now we have 14 types of data types in Python we have 14 types of data types, and and has been classified into 6 categories. Okay, 6 categories. Now what these are? First of all, I'll show you what are the categories we have, and later on I'll show you what are the data types we have, right? Okay, right. So categories, we'll start with the fundamental category is the first category what we have. Fundamental category data types. Okay, fundamental category data types. Second, we call it as sequential category data types. Third, we call it as list category data types. Fourth, we call it as set category data types. Okay. Fifth, we call it as dictionary category data types. And the last, that is sixth one, we call it as none category, or none type, you can say none category data types. Okay, so these are my 6 categories of data types we have. So one by one I'm going to explain you what we have here. Okay, The first one we call it as integer. Okay, integer comes with fundamental category. Second, we call it as float data type. Third, we call it as boolean data type, and the last one we call it as complex data type, right? Similarly, we also have in sequential also we have the same number of data types. First we have str, then we have bytes, third we have byte array, and the fourth we have called range. Similarly, in list also we have two types of data types, list itself and tuple. Okay, in set data type we have two types of data, set itself and the second one is frozen set. Frozen set. Frozen set. Okay, and in dictionary one data type we have called dict data itself, dict data. Okay, dict you can say, and in the last, that is none, also we have none. None here we have, right? So total 14 we have. You can find out 4 plus 4 8, 8 and 10 here, 10 plus 2 12, 12 and 1 13 and 14 here. So total 14 types of data types we have in Python. Okay, so one by one we are going to start with this, and one by one I'm going to explain you what are those 14 data types we have. Okay, shall we go for it?
Yes. Sir.
So first of all, I'll be explaining you what is fundamental category data type, and along with this I'll be giving you examples as well. Okay, so first of all we'll talk about what is fundamental category data type. You write like this: the purpose of fundamental category data types, you say, okay, is that to store or to allocate memory space for storing single values, okay, something like this. And in this also we have four types of data type: integer, float, boolean and complex, right? So what is integer? One by one we'll see what is integer here, okay, then we'll move to float, then we'll move to boolean and complex. So today I will complete the fundamental data type, and tomorrow, as we are going to change the link from tomorrow onwards, we will just hold the class for fundamental category. Tomorrow I will start the sequential, because sequential is the most important data type we have, and there itself we are going to start the subject, proper subject we are going to start. Okay, so do not miss any session from now onwards. So what is integer here? First I will start with the integer. The first is integer data type, I would say. Now what is integer? The integer data type is a predefined class, is a predefined class. It is predefined class in the sense which is already defined, which already present in our Python software, okay, in Python I would say. Okay, and it is used for storing integer or integral, or I would say, um yeah, integral value you can say. Okay, integral values. These values are what? Numbers without decimal points, you can say. Okay, decimal value or decimal points, you can say. Okay, in the main memory, right, in the main memory. So basically the purpose of integer data type is nothing but to store the data in the form of integer or integral values, which is nothing but number without decimal, right, in the main memory. That's it. So example I can take something like, I would say a number, let's say n is equals to, I would say 100. Okay, and let's say m is equals to also, I'll say 100. If I go for print of n comma type of n, okay, here you can check this is the type of n. So why I am saying it is a predefined class. Integer data type is a one of the predefined class. So you can see here, when I type of n, okay, when I write type of n, 100 is nothing but it is a class, the data type, okay, the type of the data is nothing but it is a integer, and integer is one of the class in our Python programming, right? Similarly you can go for m as well. You can find out here, m is also same. 100 is the data of m, and it is also the type called integer here, right? So something like this you can check. I would say examples. Okay. Similarly, you can check for some more data about this, like only searching for type. I can also go for ID as well. ID is nothing but the memory address. Okay. Here you can see this is the memory address for n. Okay. Similarly, you can go for m as well. You just print here, type here m. So you can see this is the ID, this is the value, this is the class, and this is the ID for m. Okay, both are having same value 100 and 100. So it is not creating different memory space, it is just creating a same memory space where m is also having 100 and n is also having the 100. See, this is how it creates the data, right? When we have the same value, okay, when we have the same value, even though let's say you are writing n is equals to 100 and m is equals to 100, that means pvm knows that both value are same. Okay, both value are same here. So what it will do, it will just take the same data at once, okay, and will create a memory space, and will keep this n and m both as a common, or you can say this, obviously the data is common for n and m as well, right? But both are different variables are different here, different variables, but the values are same value, I can say same value, right? So this is how it creates the memory space, even though if we have different variables, but if we have same values, it is not going to create a different memory space for it, right? It is saving the memory space like this is how Python saves the memory space. I hope it is clear, right? This is and we can perform some arithmetic operations as well, like a is equals to 100, b is equals to 200, okay, c is equals to a plus b, a plus b. I can say, if I print, okay, you just go and print c value here, okay, c, you print c here, you print c here, okay, you'll be getting 300 as the answer for this. You can also go for c is equals to a multiply with b, that is a multiplication. If you go one more time, 20,000 is the multiplication of 100 and 200. Similarly, you can go for division as well. A divisible by b. So you can check something like this. 0.5 is the answer for a divided by b. And few more things. A module floor division, you can also define it here. 0 is the floor division value for this. Like this, you can just go for some different simple arithmetic operations. Okay, I'll be giving an example here. One more thing we have, number system. Number system in integer data type, but I'm not going to explain you here itself. Once everyone get enrolled, I want everyone to be in class, and then only I will explain you this number system. Okay, the most important, you have to understand what integer does and how it converts different types of different number system data into integer value or decimal value, you can say, right? So I'll be explaining in this week itself, I'll be explaining this. But once you enroll, okay, first let everyone come into the class, then I will explain you this particular concept. Until then, we'll move to the next concept called float. So second data type is, second we have called float. So I'll say float data type. Guys, did you understand what is integer? Everyone, did you understand what is integer?
Yes.
Right, I'll go for the definition of float data type. Here also, float is a predefined class and a fundamental category data type. Okay, data type. It is used it is used for storing floating point floating point values, or we can also call it as real constant values, right? The values, the numbers, I can say the numbers with decimal places. Okay, I can say something like this. The number with decimal places. Also, we can represent the floating point value in the form of mantissa e exponentation. There is a scientific notation, we can say. We can also represent it in a scientific notation that is known as mantissa e exponent. Okay, so I can say floating point data or float value, I would say float value can be represented in scientific notation. Okay, scientific notation, that is nothing but mantissa e exponent. Okay, e exponent, that is the scientific notation of this. I'll explain you what it is. To I would say optimize usage, to optimize the usage. Now what type of usage? It could be a large value, it could be a small value. Okay, which is beneficial, I would say beneficial for large or very small values. Okay, large or very small values, or instead of this you write numbers. Okay, and number system I'll tell you later on. I'll explain you that also. I'll be giving you this. Okay, now what it is, I'll go for a couple of example for this as well. Obviously everyone knows floating point value. If I write a is equals to 220.34, this is what type of data we have here. This is known as you can see here sorry, this is known as float data. You can see 20.34 20.34 is the float data here, class coming as float here, and this is the address for this, right? Similarly, if I talk about, it is a predefined class. Obviously it is a predefined class. You can see class as float we are getting, right? It is used to store floating point values. These are this is the point value known as floating point value. As well as float value can be represented in scientific notation. What is the scientific notation? I can go something like this as well. You can define a is equals to 2.3, b is equals to 3.4. Okay, once you add this, you can go for c is equals to a plus b. Okay, So you'll be finding the C value here. C value is nothing but 5.699 and so many things, right? So when you add this, you are getting something like this. Here class is what float we are getting. Similarly, if you ask me about what is Mantis-I experimentation, it basically optimizes the memory usage or storage, you can say, right? If I write something like 3e2, check it what it is coming. D is equals to 3e2. I'll be printing print of D. You just take it what we are getting, 300.0 we are getting. Okay. If I write D something like, let's say 1 point, I'll say A is equals to 1.00001. Okay. When I execute this print of A, okay, now it is coming in a proper value. So I would say something like 1 point, some more thing I will add here, 0 point, or let's say 3 point, some more values I will be adding here. 1. So let's see whether it is working or not. 3.0 it is coming. Okay. I can say it as 0, 0, 1, and here I can say something like more zeros you add. And if you go for it 0.1, this is also coming. Okay. It should be, so 1 point I would say. Okay, I'll go for 3.00. Okay, I'll say 100000001. Actually it should not be like this. Just give me a moment, let me check once. Okay, it is coming a real constant value, but it should be a Mantis-I experimentation. See, in this case you can see here 3e2 is nothing but it represents 300.0. Okay, 300.0. Similarly, if I go for, let's say, let me check what it was. If I need to go like this here, right? So 200.001 if I say. Okay, so here it is coming as something like this. Okay, let me just copy this and clear the screen first. I'll just copy here up to this, up to this. I'll just copy it here, call it as example. Let's clear the screen first. So I'll say A is equals to 1.1. Okay, 1 point. If I say 10.01000, but it is also going to be 1 itself. I'll say 2 here, and if I print here A value, here also it is coming, because see, we are not giving up I would say longer value. Hmm. Okay, I'll write something A is equals to, But this should not be like this. Why it is coming here? It should be 3. Acha, if I write something like 4e2, okay, 4e2 means if I write something like a, here you can see it is coming as 400, right? If I write 400, something like this, okay, 400.0000001, right? So it is coming in a real constant, right? Hmm. Basically, if I write something like this also, 4 multiplied with 10 power of, it should be 2, okay. So if I use this, it is obviously it is 42 power of 2, it should, okay, it is in something like this. You can copy this one. We are getting, basically it takes the power value. Okay, so basically what I'm trying to say is this is the exponentation, right? Mantissa E exponent. What it says, 300 is the value. So it basically what it says, 300 is the value what we have, exponentation of 2. That is 10 to power of 2, right? So 300 multiply with 10 to power of 2 is nothing but, sorry, 3 into 10 to power of 2, it is nothing but 300 it is gonna give, right? So that is the Mantissa E exponentation. There is also one representation. Why this is, I guess so, it is not coming in a proper way. If I write minus 1.10000001, okay, again, I don't know why it is not coming, but I can write something like this: a is equals to 0.0000100. Okay, 1 if I write, it will, obviously it is going to give a 0.1. Okay, here it is coming, you can check it. Okay, now it is coming. So here 0.00000, we have taken 0 1 2 3 4 5 6, and the seventh value is 1. So it is saying 1 e negative of minus 0.7. Okay, 0.7, negative of minus 0.7 is nothing but after the decimal value there are first 0, then we are getting a 1. Okay, so it is a 1e minus 0.7, right? Similarly, I can do something like this, 0 point, if I provide 3, okay, so it is gonna give 3e minus 0.7. That is basically what it is saying, 10 to power of 10 to power of minus 3, 10 to power of 3 it is. Okay, sorry, 7 it is, right? So this is how it is gonna work here, but it is a negative value, 3e minus 0.7, right? So this is also, you can just take it from here. This is how it works. This is called Mantissa E exponent, right? And basically it works with the, like, it works with mathematical concepts, right? Last one, that is a complex value, we are going to see here. Complex value, complex value is nothing but, I would just write it here. What is complex? Complex is also one of the data type. Okay, complex is all, sorry, boolean we have. So let's do one
You
thing,
didn't
I
say
will,
Boolean.
sorry.
You didn't say Boolean, I'm saying.
Boolean. That's what I forgot. Boolean. Boolean. I'll do one thing. This Boolean and complex, I'll complete it tomorrow. Okay, because I need some time to explain this Boolean and complex here. Okay, shall we stop it here?
Yeah.
So
Yeah,
tomorrow
okay.
I'll be explaining this Boolean and complex. Okay. Thank you so much, guys. So see you tomorrow. Have a great day, and keep practicing. Bye bye. If you have any question, you can ask me now.